A uniform flexible chain of mass m and length L hangs in equilibrium over a smooth horizontal pin of negligible diameter. One end of the chain is given a small vertical displacement so that the chain slips over the pin. Find the speed of the chain when it leaves the pin. What I understand is there is a chain which passes over a pin like this. That is, this is a uniform chain, and half of the chain is hanging on one side, another half is hanging on the other side of this pin. Then what will happen if you slightly disturb it? This end will come down and this end will go up, and the chain eventually it will slip over this pin. So as the chain is slipping over, the moment the last link is just about to leave the pin, the entire chain might have got vertical and it is falling down. So our job is to find out the speed of the chain when it leaves the pin. That means exactly at this particular orientation, what is the speed of the chain. What you do is, we will do it with the mechanical energy conservation. I take this as our reference level. That is, the reference level is at the position of the pin, the peg that has been given here. Now think over it. The entire mass is m. That is, half of the chain having mass m by 2, another half is having mass m by 2, and each length will be equal to L by 2, L by 2. Now please remember, for a vertically hanging chain, the gravitational potential energy, while calculation we will take the mass of the total hanging position and g and the distance up to the center of mass of the vertically hanging position. Please keep in mind. So, with reference to this level, what is the initial gravitational potential energy of this particular arrangement? Let's check. This is one vertical position, is it not? Then what is the mass? This mass of this part is equal to half, that is m by 2. So, first of all, as the entire chain is below the reference level, put a negative sign. The gravitational potential energy will be negative. Then the mass of this portion is how much? It is equal to m by 2 into g. And what is the distance up to the center of mass of the hanging point? This is total length is L by 2, half of that is L by 4. And same thing is repeated for the other one, that is minus the mass is m by 2 g and the distance up to the center of mass is L by 4. So finally what we get as this is equal to minus mg into L by 4. Now when the chain is just about to leave contact with this pin, the entire chain has become vertical in one line. Therefore, what is the gravitational potential energy in this final state? It is equal to minus, of course negative, and the total mass will be m into g into the distance up to the center of mass, we can take it as L by 2. Now using the principle of mechanical energy conservation, initial energy there was no kinetic, and it is final energy is uf plus the kinetic energy when it is just moving at this moment with a velocity v. So let's put the value what we were thinking here. It is equal to minus mg into L by 4, and this is minus mg into L by 2 plus half mv square. Simplify it, we have v is equal to root over g L by 2. This is the speed of the chain when it is completely become vertical in one line and the one end of the chain is just about to leave contact with the pin.